Welcome back. Last time around, we talked about paging from the database as a single source of truth and how the remote mediator makes it possible. We also show how to monitor the loading states of the pager using the load states flow exposed from the paging adapter. With the fundamentals of the paging library covered, let's go over some operations we can perform on the data page through, specifically transformations. It is unlikely the data pulled from the paging source is ready to be bound to the UI as it's fetched. There usually needs to be a few things added for additional context, ranging from metadata like separators to additional fields in the list item model class. Fortunately, the paging library provides us with the ability to map, filter, and perform other transformations to help create the models the UI needs to render fully. Let's get into an example. In the project we've been working on, we fetch repositories and display them in a flat list. This is functional, but can be improved from a presentation perspective by sectioning the list to give a user a better sense of placement in the infinite dataset. A great way to section the repositories is by grouping them by how many stars they've received. We can do this by inserting a separator between consecutive items in a list that have a star count boundary between them. We start by operating on a stream of paging data. The paging data type exposes transformation methods directly. In our case, we first map the raw repo type to the UI model type. For newly transformed paging data of repo items, we can then insert separators between them. The insert separators method gives us access to consecutive items in the list, allowing us to place separators where they might be needed. Let's revisit our app and its functionality. The app lets users perform a free-form search for repositories that match their query. Since each distinct query fetches a distinct set of items, each query will need a paging source that supports it. This is an important point. A pager is a class that loads data incrementally from a paging source and therefore is wholly dependent on its paging source for the manner in which the data is presented. For query-based paging sources, significant changes to the query, like with searches in this case, will need a new pager. Other examples of this scenario include changing sort order of items, filtering really large queries on the database level, and so on. Remember, a pager is a window into a set of ordered data. If a new query does not match the original order, you should create a new pager. Check out episode 1 of this series for a quick refresher on how. Finally, throughout this series, we've been using the PagingData adapter to display paginated items in the UI. However, this isn't strictly necessary, as the paging library allows you to bring your own recycle view adapter. This is achieved with the async pager data differ, and it's what the PagingData adapter uses internally. The async PagingData differ exposes the load state flow, the item count, a refresh method, a retry method, and much more. If you find yourself needing more flexibility or customization, the async pager data differ offers a fantastic way to take advantage of most of the abilities and conveniences of the paging library through delegation. It is always worth taking a look at the source of the paging data adapter to see how it delegates to the async pager data differ as a starting point for your own exploration. That's it for this math skill series on the paging library. In this episode, we covered transformations paging data offers, discussed the pager's dependency on its paging source, highlighted scenarios that require a new pager to be created, presented an overview of the async page data differ, and shown how it can be used to bring your own recycler view adapter. Thanks for tuning in to this math skill series on the paging library. We've got so much more great stuff coming your way, so keep tuned and we'll catch you in the next one.